Dimensions of physical quantities. Dimension denotes the qualitative nature of a physical quantity. Dimension denotes the qualitative nature of physical quantity. Let me explain this. For example, distance from home to college or school. For example, the distance from home to college is 80 meter. 80 meter. And the distance and the displacement from home to college. Displacement is the shortest distance, and the displacement is, for example, 50 meter. Distance is 80 meter, displacement is 50 meter, and the radius of this circle for example, the radius of this circle is 2 meter. The radius is the distance from the center of the circle to the circumference. Take another example. For example, the length of this box is 3 meter, and the height or width of this box is 2 meter. Now, distance in meter, displacement in meter, length in meter, width in meter, radius in meter. Meter, same unit. They all have same unit. Length, width, height, distance, displacement, and radius. They all are measured in meter. They all have same unit. So they all have same dimension. And the dimension is L, capital L. The unit is meter. Now, the unit is meter, the dimension is capital L. The unit is the unit of length is meter. Distance is the length. Distance is the length from home to college. Displacement is the shortest length from home to college. Length, width is also length from this point to this point. Radius is also length from center of the circle to the circumference. It's also a length. So they all have same qualitative nature and same units, meter. Dimension denotes the qualitative nature, and they all have same qualitative nature because they all share same dimension, or they all have same dimension or one dimension. It means they have same qualitative nature. So dimension denotes the qualitative nature of physical quantity. For example, length, width, height, distance, radius, all are measured in meters. Meter, all are measured in meters because they have same nature, and thus they share same dimension. Now, an important short question that may come in exam. Note down this question. I'm repeating, note down a possible short question that may come in exam. The question is, why do length, width, height, distance, displacement and radius have same dimension? The question is, why do, a short question. The question is, why do length, width, height, distance, displacement and radius have same dimension? The answer is from here up to here. The answer of this question is from here up to here. Or in short, simple word, the answer is they have same qualitative nature. They have same qualitative nature, that's why they share same dimension. Now, dimension is represented by a capital letter enclosed in a square bracket. A capital letter. A capital letter. Capital letter, capital letter, capital letter. Now, these are the dimensions of base quantities. These are the dimensions of, the dimension of length is capital L enclosed in a square bracket. The dimension of mass is capital M enclosed in a square bracket. Unit is kg, dimension is capital M. Dimension of time is capital T enclosed in a square bracket. Dimension of electric current is capital I enclosed in a square bracket. Dimension of temperature is theta enclosed in a square bracket. Dimension of amount of substance is capital N enclosed in a square bracket. Dimension must be in capital letter and must be enclosed in a square bracket. The dimension of intensity of light is capital J enclosed in a square bracket. Dimension is represented by capital letter enclosed in a square bracket, like mass, dimension of M, L, dimension of length, time, dimension of T, dimension of time. Now, these are the dimensions of base quantities. Now, dimensions of derived quantities. Dimension of derived quantities. In previous lecture, we learned how to find the dimensions of derived quantities. Let me repeat. In previous lecture, we learned how to find the dimensions of derived quantities. We learned the how to find the dimensions of force, which is mLt power minus 2. We learned how to find the dimensions of velocity, which is Lt power minus 1. If someone missed that lecture, so make sure you must go through it first for better understanding of this lecture. I'm repeating, if someone missed that lecture, first go through that lecture for a better understanding of this topic. And the title of this lecture was Derived Units in terms of base units. The title of the previous lecture was Derived Units in terms of base units. In that lecture, I explained how to find the dimensions of derived quantities. Now, dimension of force is mLt power minus 2. M is multiplying with L and dividing by T square. So, multiplying and dividing the base dimension of base quantities. These are the dimensions of base quantities. mLt. These are the base dimensions. They are dimensions of base quantities. There are only 7 base quantities, and the dimensions of these are the dimensions of base quantities. So by multiplying the dimensions of base quantities, we get the dimension of derived quantity. Force is the derived quantity. So dimension of derived quantities are obtained by multiplying or dividing. Multiplying, M is multiplying with L, dividing with T square. Multiplying or dividing the dimensions of base quantities, we obtain derived quantities. These are the examples. Now, dimensionless dimensional variables dimensional constants. Dimensionless variables, dimensionless constant. Here, dimensionless means no dimensions. Dimensionless means no dimension. Dimensionless means having no dimensions. Dimensionless means having no dimensions. Dimensional means having dimensions. Dimensional means have dimensions. Dimensionless means no dimension. Dimensional means have dimensions. Now, variables. Dimensional variable. Variables means variable in magnitude. Variables means variable in magnitude. Constant mean constant magnitude. Variable means variable in magnitude. Variable magnitude. Constant mean constant magnitude. The answer of this question is also given in the question. Now, dimensional variables. Dimensional means having dimensions, or variables means variable in magnitude. Those physical quantities that have dimension and variable in magnitude are called dimensional variables. Dimensional constant. Constant magnitude. Dimensional means have dimensions. Those physical quantities that have dimensions and a constant magnitude. For example, GCH, or I'll explain. Dimensionless variable means those physical quantities that have no dimension. Dimensionless means no dimension and have variables in magnitude and have variable magnitudes. For example, strain, theta, angle, coefficient of correction, etc. Dimensionless constant mean those physical quantities that have no dimension and have constant magnitude are called dimensional constant. For example, 1, 2, 3, pi, or exponential e, etc. Now, it's a basic trick to remember it. Now, let me explain these examples. Dimensional variables. The example is velocity, force, acceleration, work. Velocity. Sometime the magnitude of velocity varies, numerical to numerical, situation to situation. Sometimes the velocity is, for example, 50 meter per second. Sometimes the velocity is 40 meter per second. Sometimes the velocity is 8 meter per second. The magnitude varies according to situation or numerical to numerical. The magnitude of velocity varies, and the dimension of velocity is L t power minus 1. The magnitude varies. Sometimes magnitude is 50, 40, sometimes 8, and maybe it can vary. So, the magnitude of velocity vary, but also have dimension. Variable, dimensional, has dimension and magnitude varies. So, velocity is the example of dimensional variable. Dimensional means having dimension, variable means varies. So, it varies and have dimension. So, velocity is the example of dimensional variables. Same force. Sometimes force is 5 Newton, sometimes 10 Newton, 80 Newton. It keeps varying. So, and force also have dimension. MLT power minus 2 have dimension and magnitude varies 5, 6, 8, 10, variable in magnitude. So force is an example of dimensional variables. Same story for acceleration, work, power, pressure, and many more. It is. Now dimensional constant. Dimensional means having dimensions. Constant means the magnitude is constant or fixed, not varying. For example, the speed of light c. The speed of light c, the speed of light is 3 multiplied 10 to the power 8 meter per second. The speed of light c is 3 multiplied 10 to the power 8 meter per second. The speed of light remains constant even on earth, in space, or in solving numerical. The speed of light is 3 multiplied by 10 to the power 8 meter per second. It's a constant value. And the dimension of speed velocity is same, L t power minus 1. A constant value and having dimension. Constant dimensional mean have dimensions. So speed of light is the example of dimensional constant c. Same g. G is gravitational constant, and the value of g is 6.67 multiplied 10 power minus 11 Newton meter square per kg square. So 6.67 multiplied 10 power minus 11. The value of g is constant, fixed, and also has dimension. Same story for Planck's constant h and universal gas constant r. So these are the examples of dimensional constants. Now, dimensionless variables. Dimensionless means something that has no dimensions. No dimensions. Strain. For example, strain. Strain is the ratio of change in length divided by original length. For example, the change in length is 0.5 meter and the original length is 12 meter. Meter will be cancelled out with meter, and after simplification the value will be 1 hour 24 with no units, because the both meters are cancelled out with each other with no units. So strain is unitless and dimensionless. Strain is unitless and the velocity has unit, meter per second. That can't be cancelled because they are different physical quantities. The meter length, they are same physical quantities, same units, so they will cancel out with each other. And there is no unit, so strain is unitless and dimensionless. Unitless and dimensionless, but the value varies from numerical to numerical or situation to situation. So no dimensions, dimensionless, but variables. The value of strain varies from material to material or numerical to numerical. So strain is the example of dimensionless variables. No units, no dimension. So it's dimensionless and value varies, so variable, dimensionless variable. Same phenomena for angle. Angle is also the ratio of two similar quantities. The ratio of arc length and the radius, both are in meter, same. So angle is also unitless and dimensionless. Coefficient of friction. Coefficient of friction is also a ratio of two similar physical quantities. The coefficient of friction is the ratio of a frictional force to the normal force. Both are in Newton. Here both are in meter. The coefficient is both are in Newton. So the Newton will be cancelled out with Newton. So the coefficient has unit less and dimension less. Same now dimensional constant. Dimensional constant means, for example, pi. The value of pi is 3.14 with no units and no dimension. So the value of pi doesn't change, it's a constant. So pi is the example of dimensional constant, dimensionless constant, no dimensions and constant value. E, exponential E, it also has a constant value. Exponential E is 7, I think 7.12 something, the value of E. So no units, no dimensions, same 1, 2, 3, the numbers. The number are constant with no units, so they are dimensionless and have constant value. These are the examples. Hope you got the point.